have this Organoid tech in research video. It's a pretty decent video, trying to turn it into a web application. That's the kind of things we do. And now with the new model, maybe we can do it even better. We updated this real-time signal amplification microscope thing. Now it should work better. Before we had an issue with the frames per second. Yeah, so apparently on most devices it's not stable. What do you know? Well, we didn't know. I thought it would be stable on my device. This keeps fluctuating. I thought the camera is like 30 FPS, but then it's trying to do something else with it. Yeah, I'm not sure what it does, but yeah, it says the inputs are resampled at stable 30 Hz per. That's for the calculation of the beats per minute. And I did test it, it's working okay. Can test it again. And it is deployed on the site. Don't forget to control F5 it to see the most recent version, because we did redeploy yesterday. Yeah, that audio AI is only working on Chrome. I'm not actually using Chrome. Well, I am, but never mind. It's not working on any browser for whatever reason. Yeah, so on this channel, on this YouTube channel, we develop all the web applications, then they go onto the website. Yeah, some videos are for members only. They essentially get released. So whichever, this will be released midnight tonight and like midnight every day. So essentially for you to see this one, you'll have to like wait five days and it will be out. So no problem, not a problem. But if you do want to support this channel, you can become a paid member. And then you get access to them early. Yeah, so, and then it's all available on the website, BioniChaos.com. We had an overview of this, EpiMinder device. So this is Gemini, there's both models. The new one, whatever, the fast and the thinking model. I did this overview of it, and we had an audio review. I generated this table. Let's look at the table. Yeah, I'll go over this together. But yeah, essentially the prompt was a critical review of EpiMinder device compared to other tools, talk about false alarm rate. And we turn it into a conversation between two data scientists.
You have to see the specs on this EpiMinder device. It just got FDA marketing authorization via the De Novo pathway. We are talking about the first true sub-scalp continuous EEG monitor. It's effectively a Fitbit for the brain, but with medical-grade fidelity.
Sub-scalp. You know, marketing teams usually work very hard to avoid the word scalp. It sounds like a threat from a 19th century Western. So they slice you open and shove a Fitbit in there?
It's minimally invasive. It sits between the skull and the skin, behind the ear. The key is the data stream. Unlike the NeuroPace RNS, which is intracranial, literally inside the skull, and only records snapshots when it detects a seizure, the Minder streams 24/7, continuous, years of data. The Umpire trial had a patient recording for over 5 years.
5 years? That's a lot of data. That's like recording every conversation I've had since 2020. Most of it is just me asking where my keys are. Who is watching this 5-year movie of my brain?
That is the critical data science challenge. It's the big data problem. You cannot have a neurologist review 8,760 hours of EEG per year. The signal-to-noise ratio would destroy them.
Exactly.
If I'm the doctor and I have to watch a 5-year live stream to find 3 seizures, I'm quitting. I'm becoming a gardener.
This is where the false detection rate, FDR, becomes the most important metric in the industry.
Hit me with the numbers. How often does this thing cry wolf?
So deep learning models, like CNN BLISTM networks running on this sub-scalp data, are getting very good. The current benchmark for these algorithms is roughly 1.1 to 2 false detections per day, while maintaining about 90 to 94% sensitivity.
2 a day? Misha, that sounds low, but do the math. That's 730 false alarms a year. If my smoke detector went off 730 times a year when there was no fire, I wouldn't change the batteries. I'd move house.
But you have to compare it to the alternative. A standard scalp EEG is only 72 hours. You miss everything. And consumer wearables like the Empatica Embrace 2, they're great, but they rely on accelerometry and EDA, sweat and motion. They have a low false alarm rate for convulsive seizures, around 0.05 to 0.7 per day, depending on the setting. But they are almost totally blind to focal seizures, where you just zone out.
Okay, so the wristwatch misses the quiet seizures, the brain implant catches them, but also flags every time I chew a bagel too aggressively.
Chewing artifacts are actually a huge issue for EEG, yes, but EpiMinder solved the doctor burnout problem with a human-in-the-loop cloud architecture. The device doesn't ping the doctor directly.
Ah, the middleman, the unsung hero.
Precisely. The data goes from the implant to a wearable unit, then to the phone, then to the Minder cloud. There, sophisticated algorithms do the first pass, and then, this is key, trained clinical staff, technicians, review the flagged events. They scrub the false positives before the report hits the neurologist's desk.
So there's a guy named Steve in a cloud center somewhere, watching my brainwaves saying, nope, that's not a seizure. That's just Yazik listening to jazz fusion again.
Effectively, yes. This filter is what makes the system viable. It turns 700 false alarms into a clean report of 12 confirmed seizures. It gives the doctor objective truth. The Umpire trial showed that this data changed the treatment plan for nearly 90% of patients.
That is impressive. But wait, you said wearable unit. I thought this was an implant.
It is, but you need to power it and get the data out. You wear a small external processor behind your ear, held on by a magnet. It charges the implant inductively.
There it is, the catch. I have to charge my head.
You charge the external unit. If you don't wear it, you get data gaps. Compliance was actually one of the challenges noted in the trial.
I forget to charge my toothbrush, Misha. You're telling me if I forget to charge my ear magnet, my $25,000 brain implant becomes a paperweight?
A temporary paperweight, but the benefit is seizure forecasting. That's the holy grail. They're finding that seizures follow multi-Dean cycles, long rhythms over weeks or months. With this continuous data, we could eventually give patients a weather report for their brain, an 80% chance of seizure on Tuesday.
Okay, I'll admit, that's cool. It's like Minority Report, but for my own nervous system. So, verdict.
From a data standpoint, it's a revolution. It fills the massive gap between guessing and knowing. The false discovery rate is high for raw algorithms, but the service model solves it.
And from my standpoint, it's a lot of commitment. But if it stops me from waking up on the floor wondering why my tongue hurts, I guess I can learn to charge my head.
Okay, we want to find more information on the false positive. So, comparing different types of seizures, we would like to compare the false positive rate for the different devices. So we have 3 variables. False positive is what we mainly looking at. Then we have the type of device and the type of seizure. Then we'll generate the conversation again. Okay, so I have now a table. comparison matrix for false positive rates, device type, wearable, EpiMinder, NeuroPace. Wait, where did the regular EEG go? Okay, we also want to include the standard EEG recording. And yeah, maybe with the standard EEG recording, break it into the duration of recordings. Okay, so we have standard EEG, a ambulatory EEG, so take home, a video EEG, hospital. Now to remove the NeuroPace device. Okay, so I have NeuroPace, EpiMinder, standard EEG, ambulatory EEG. It's always getting rid of one. And we had the wearables. We had the variables as well. The table is missing variables. The table is now missing wearables. Can we make the table complete? And we also wanted to include the different type of seizures. Yeah, so we want the device, include the NeuroPace. We want the table to have device, recording type, primary target, false positive rate, and what happens on false positive. Now the device should have NeuroPace, EpiMinder, standard EEG, ambulatory EEG, wearables. The recording type should have the details of what is being recorded. Primary target is what the types of seizures are targeted. A false positive rate should have the FPR, also explain what FPR is. And yeah, for NeuroPace, when a false positive is happening, there is a brain stimulation. Now, before you said the device stimulates the brain unnecessarily, you feel nothing, but the battery life decreases. Well, I don't think the battery life is the most devastating outcome of a false positive. So, for EpiMinder, you said what happens in a false positive event, data burden. They have like junk data, chewing sleep as seizures. Your doctor must manually delete this. Well, the doctor would not be looking at the raw data, so it could lead to misdiagnosis. Okay, so we updated the table. So NeuroPace, what happens on false positive data lost? Data loss, the real risk. The device simulates the brain unfelt. Critically, it fills the limited memory buffer with junk. Okay. Potentially overwriting the record. Yep. So the EpiMinder misdiagnosis ring. They have like chewing as a seizure. If the review team or doctor does not filter this out, the patient may be prescribed drugs for seizures they do not have. Standard EEG, overinterpolation, ambulatory EEG, reviewer fatigue, loose wires, and okay, so that sounds more or less legit. Okay, that sounds legit, and we had the prompt. Funnily enough, EpiMinder is actually going for an IPO, which is super weird because I thought you actually have to be selling something. But this one is still in a clinical trial, as far as I'm aware. So there's no product on the market. So I don't know. That's a really bizarre idea to go for an IPO. But they can do what they want. They're raising lots of money. Is it another Theranos though? Likely. Very likely. Okay, I have another review. It's being generated. So it's brought to you by Gemini, so whatever. Yeah, if you wanna complain to Gemini. Or any information you published online. Probably a good idea to remove it or something. The Toxin is not working, is it? Is it even correct? It seems like the shortcuts are working, but the... Here I have sound to it. We really need an expert to tell us if it's doing anything useful or not. Injecting growth factor. Yeah, that's working. Well, it's doing something. Let's say it's working. Inducing differentiation. What's that mean? How do you add the toxin? Does it seem to... Wait. Yeah, the buttons. What? The buttons are not defined. Okay, I'll come back to this one. See what's wrong with it. Well, while we doing something else, we get the bot to redo the code. I don't think it's completed the code as I will see. Yeah, we haven't have a review.
You realize the entire epilepsy monitoring industry is essentially a class imbalance nightmare, right? We are trying to detect a signal that happens 0.01% of the time in a dataset that is 99.99% noise. Statistically, it's a disaster waiting to happen.
Class imbalance? Is that why my gym class has 30 people and only one working rowing machine?
No, it means seizures are rare. If you build a detector that is 99% accurate, but the event only happens once a month, your false discovery rate is going to be catastrophic. You're going to have 10,000 false alarms for every real seizure.
I actually get this. My Apple Watch called an ambulance once because I was whisking eggs too aggressively. It thought I fell off a roof.
Exactly. That's the wearable problem. They rely on accelerometry. Your whisking motion has a frequency of what? 3 hertz? A tonic-clonic seizure is also rhythmic movement. To a dumb algorithm, making an omelet equals grand mal seizure. The false positive rate is through the roof, around 0.2 to 2.5 per day.
So I'm terrifying my family because I like a fluffier scramble. Fine. But what about the cyborg stuff? The brain chips, NeuroPace. Surely if you drill a hole in my skull, the machine knows the difference between brainstorm and breakfast.
You'd think so, but the NeuroPace RNS has a completely different fatal flaw. It's a triggered system. It's not recording a video, it's taking snapshots. It has a circular buffer that can only hold about 12 minutes of data total.
12 minutes? My toaster has more memory than that.
It's an implanted device. Battery and storage are finite. So it sits there waiting for a trigger, a specific brainwave pattern. When it sees it, it records a clip. But here's the horror story. If you set the sensitivity too high, it detects noise as a seizure.
Okay, so the doctor sees a few junk files. Who cares?
No, Yojik, you don't understand the architecture. It's first in, first out. If you have a false positive storm, say 50 false detections in an hour because you were stressed or dehydrated, the buffer fills up with garbage.
And what happens to the recording of the actual seizure I had 2 hours ago?
Overwritten, gone, deleted. The device saw it, but because it panicked over the false alarms, it pushed the real evidence off the cliff. It's called buffer saturation. The doctor downloads the data and sees 50 clips of nothing and 0 clips of the actual seizure you had. You lose the true positive because of the false positives.
That is remarkably stupid. It's like a security camera that deletes the footage of the bank robbery because it saw too many pigeons in the parking lot afterwards.
Precisely. That's why EpiMinder is theoretically the solution. It's continuous sub-scalp EEG. It doesn't wait for a trigger. It records 24/7, year-round. No buffer saturation because it streams everything to a cloud server.
Finally, the CCTV that never sleeps. So EpiMinder is the winner. No lost data.
Well, now you have the opposite problem. You have the big data problem. You have 8,760 hours of brainwaves per year. A human neurologist can't look at that. They have to use an AI algorithm to find the needles in the haystack.
And let me guess, the AI is also an idiot.
The AI is sensitive. The EpiMinder sits under the scalp, right? But it's outside the skull. Do you know what else is outside the skull?
My crushing sense of existential dread.
Muscles, specifically the temporalis muscle, the one you use to chew. When you chew gum, that muscle fires electrical signals that look shockingly like a focal seizure on an EEG.
So if I'm eating a steak, EpiMinder thinks I'm having an episode?
Potentially. We call it the chewing artifact. If the algorithm is tuned to catch faint seizures, high sensitivity, it will flag every meal as a seizure cluster. You end up with a false positive rate of maybe 5 to 10 events a day.
But you said EpiMinder is better because it doesn't delete the real seizure.
It doesn't delete it, but it buries it. If the doctor receives a report saying 3,000 seizures this year and 2,950 of them were you chewing gum or sleeping, sleep spindles also look like seizures, the doctor might just throw out the whole report. Or worse, they believe the report.
And they prescribe me enough anticonvulsants to sedate a horse because I like beef jerky.
Exactly. That's the misdiagnosis risk. With NeuroPace, you get undertreatment because the data was overwritten. With EpiMinder, you risk overtreatment because the noise was counted as data.
So the only way this works is if a human actually sits there and checks?
Yes, that's the hidden cost. EpiMinder isn't just a device, it's a service. You need a human in the loop, a poor technician in a basement somewhere scrubbing through your chewing files to find the one real seizure so the doctor doesn't accidentally overdose you.
The future of AI is incredible. We built a supercomputer to read minds, and now we have to pay a guy named Dave to verify that I was just eating a sandwich.
Statistically, yes.
Okay, so I have the Gemini code assist modifying the code. Yeah, we expanded the demo. Demo is now more comprehensive. Do you know what happens with, what is it called, the red ones? Yeah, and the demo mode doesn't stop when you interact with the page, but that's okay. So you can play together, you and the bot. So when they die, the tone actually disappears. Okay, so when we have necrotic cells, aren't they meant to just eventually fade out and die? Or do we have to reset the simulation every time? Just go with that as a prompt. It's not agent mode. Well, because we need an answer. Give me an answer. Yeah, to effectively clear out the necrotic cells. Currently we have to reset the simulation. Okay, so how difficult would it be to actually, instead of cycling through the simulation, having the cells dying out naturally? I can't turn on agent now that we use the regular chat. Okay, so made changes. Okay, they actually die out, so that's working really well. Thank you very much. Okay, but we would like to update the demo mode to showcase the def as well. So instead of resetting, we would like them to just naturally cycle through and die naturally. Can I do it? Just updating the demo. Not even sure which model it is. It's a Gemini Code Assist. You can't actually select the model, but that's okay. Okay, we're having the demo updated. Turn on the sound. The sound is off by default. Okay, so we have a growth factor, some more, then inducing differentiation, whatever that means. Okay, and we have some stress, toxins, whatever, and cells dying. But then the simulation is eventually reset. So why is the simulations eventually reset? Yeah, we would like the simulation to just cycle continuously without resetting and the cells just dying out naturally. Yeah, I want to make sure we're using the Gemini Pro. So we'll do it both in AI Studio and using Gemini Code Assist. See which one gives us better results. Okay, we'll do the change from Code Assist first. Now it should just cycle through without resetting. The demo should start after 10 seconds. Yep. Growth factor. Some more growth factor. Inducing differentiation. Okay, now applying toxic stress. Then it just dies out. So we'll just do its own thing. It tells you what it does on the screen. I didn't see the decay. The growth doesn't work. Okay, so I have Gemini change the start demo. Okay, can we regenerate and update the whole code? Now, I know I can integrate that one function, but I suspect there would be other things that would need updating. Currently we have 771 lines of code, so it should not be significantly shorter than this. You know, it's got rid of all the cells have died, and then it's trying to inject growth factor, but there is nothing to inject it into, I think. The question, what happens when we have both me interacting with the page and the demo is running? Okay, so it killed some amount of cells, but not a significant amount. So this would just supposedly will keep going forever. Did it update? Okay, we'll continue this next time. Everything we do eventually becomes available on BioniChaos.com. Go check it out, provide your feedback. Don't forget to like, subscribe, so you don't miss the next live stream. And I'll see you in a bit. Bye.